what sine of, say, 60 degrees, and I knew what it was, you're going to know what it is after today without a calculator. So it's pretty exciting. Okay, so a unit circle, the definition of a unit circle is the unit circle has a radius of, does anybody know? 1, and the center is at the origin. Nobody wants to talk because they're getting recorded here. Okay. So we're going to use the Pythagorean theorem to come up with the equation of this unit circle. So I'm going to draw a triangle, just like we learned yesterday, with, here's my theta. And what's this length right here called? X. And what's this length right here called? Y. And so we're going to use Pythagorean theorem. And what did I say for, it was R, but in this case, because it's a unit circle, the R is going to be 1. 1. Okay, so does anybody know what if I use Pythagorean theorem, what my equation would end up being? What's this length? X squared in Pythagorean theorem plus y squared equals 1 squared. So what's my formula? X squared plus y squared equals 1. So that's the equation of the unit circle. X squared plus y squared equals 1. Okay, so remembering that sine was y over r and cosine is x over r. But now because this is the unit circle, we're talking about the unit circle specifically, our r is 1. So what happens when I take y and divide by 1? I get y, right? So that means sine theta in a unit circle is actually the y coordinate. Cosine, cos is x divided by r. So if I take x and I divide by 1, what do I get? X. That means, again, in the unit circle, my x coordinate is cos theta. 1. So tan is y divided by x. So we can't simplify that with a radius. But what do we know? Y is our sine and x is my cosine. So this is actually sine theta divided by cosine theta. So this point right here is x comma y. This is also cos theta comma sine theta now in a unit circle. You see that? So we're going to know the exact values on the unit circle. They're specific angles, and they are the 30, the 45, and the 60. These values have to be memorized. Okay? No calculator. To determine these exact values, we will use the unit circle, where the value of the radius is always 1. Families of angles are those who have the same, now we were talking about this yesterday, reference angles and related angles. Remember we were talking about this? Yes? So if I get a 30, that means in each, these are the reference angles. So anything that has a reference angle of a 30 will have the same, be in the same family. Anything that has a reference angle of a 45 will be in the same family. Anything that has the reference angle of a 60 will be in the same family. So it has the same reference angle. Any member in the same family will have the same trig ratios. Remember we drew that reference triangle yesterday of this with the different related angles, and they ended up having the same trig ratio. Okay, so now I'm going to show you where these values actually come from. Okay, so I'm going to draw a reference triangle right there. Okay. Can anybody label one of the lengths or more of this triangle that we know? The only thing I know is this is 1. And so basically I have unknowns here. This is an x and this is a y. So I could come up with the same formula, x squared plus y squared equals 1. But there's something very unique about the 45-degree triangle. The 90. What? The other angle is 45. It's an isosceles triangle. So, and what does that mean if that's 45 and that's 45? Yeah? Yeah? I'm talking about, what do you know about the lengths, though? They're the same, yes. The x and the y are the same length. So what I'm going to do here is I'm going to say y is equal to x. And now I'm going to use Pythagorean Theorem. Instead of saying x squared plus y squared equals 1, I'm going to do x squared plus x squared equals 1 instead of using a y. Now, does anybody know what x squared plus x squared is? 2x squared. 2x squared, 2 of them, right? If you have one x squares and another x squares, you get 2 of them. Okay, and then I'm going to do some algebra skills. I'm going to divide by 2. So I get x squared equals 1 over 2. Yes? And then I'm going to do what? To get what x is. How do I get x squared into x? Square root it, yes. So I get the square root of 1 over 2. And somewhere you learned that you could simplify this. You can rewrite this as the square root of 1 over the square root of 2. And of course, everybody knows the square root of 1, hopefully. What's that? What's the square root of 1? 1? So 1 over root 2. Yes? Okay, and so eventually in one of the units, we learn how to what's called rationalize the denominator. And so this is a fraction that has a radical as a denominator. Later on, we learn how to rationalize. And I just want to mention this because some of the answers might not, I don't think so, might have this as an answer, root 2 over 2. And just for fun, just to verify that these are exactly the same values, I want you to take this and put it in your calculator and look what the decimal equivalent is, and this on your calculator, and verify that they're the same. Just remember that when you have a radical and you have a graphing calculator, you have to close the brackets. Otherwise, it thinks it's the square root of 1 because it thinks it's the square root of 2 divided by 2. Can anybody verify that's true? Okay, right on. Okay, so let's go back to the beginning. What did we discover? Sine theta is my y value. Cos theta is my x value. Yes? So what's my x value here? 1 over root 2. What's my y value right here? 1 over root 2. Guess what? What is sine of 45 degrees? 1 over root 2. What's cos of 45 degrees? 1 over root 2. Just in case you don't believe me, go on your calculator and find sine of 45 degrees. Was that not the 1 over root 2 that you just figured out? Try it. It is. It is. So sine of 45 degrees is 1 over root 2. Cos of 45 degrees is 1 over root 2. Now for superstar status, who can tell me what tan of 45 degrees, without a calculator, just using the knowledge that tan is sine theta divided by cosine theta? Who said it? It's 1. Very good. Very good. Does everybody know how I got that? I just took that and divided by that. Well, if you take something and divide by itself, it's 1, right? Okay. So 45 degrees, it's in quadrant 1. What's sine theta? 1 over root 2. What's cosine theta? 1 over root 2. What's tan theta? 1. Okay, so now what we're doing is, that was this triangle right here with the 45 degrees. Do you see? Now I'm going to go into the second quadrant with the reference angle 45 degrees, but this time I want to do that angle. And what angle is that? 135. So we learned yesterday that the ratios are the same. Like this length is the same as this length. The only thing that changes might be the sign, the sign of the positive or negative depending on which quadrant it's in. Okay, so 135 is in quadrant 2. What's sine of 135 degrees? 1 over root 2. Why is it positive 1 over root 2? Yeah, do you remember the cast rule? Yes? Sine is positive in that quadrant. Yes? Okay, what's cosine of 135 degrees? Negative 1 over root 2. Very good. And what is tan of 135 degrees? Negative 1. Hey, you're catching on. Okay, now if we go into the third quadrant and draw that same 45-degree triangle, you see that? And go all the way to this one, that would be 225. Does everybody agree? Okay, so what is sine of 225 degrees? Is it positive 1 over root 2? No, now it's in the third quadrant. Only tan is positive. So it's negative 1 over root 2. What's cosine of 225 degrees? Negative 1 over root 2. And what is tan going to be? Positive 1. Very good. Okay, again, I'm going to draw the 45 in the fourth quadrant and go all the way around. And that's 315 degrees. That's the related angle in that quadrant. What's sine of 315 degrees? Negative 1 over root 2. Very good. What's cos of 315 degrees? Yes, it's going to be positive 1 over root 2. And then tan of 315 degrees? Negative 1. Very good. Okay, so we're going to memorize these things. I am going to give you a little trick of how to memorize these things. But yeah, you're going to have to know if I say any related angle, sine, cosine, tangent of this, right? Without a calculator. Okay, now we're going to go to the 60 family. I'm going to draw the right triangle. And if this is 90 degrees here, and that's 60 degrees, what's the remaining angle there? 30. Because somewhere we learned that a triangle adds up to 108, the inside angles add up to 180 degrees. Okay, in order to do this though, I'm going to draw two triangles like this. And if I outline this in red, what do you know about that big triangle there? It's an equilateral triangle. Very good. And what do you know about equilateral triangles? All three sides are the same. Can anybody tell me one of the sides we know? Yeah, we know that this is 1 right here, which is that side there. It happens to be that side, which means this side is 1 as well. Do you see that? Okay, but because these are equivalent triangles, I know for a fact that this must be how much? A half now, because the two have to add up to 1, right? Okay, so again, I don't know what this height is right here, so I'm going to call this what? Let's call it y. Why am I going to call it y? Because that's the height of that triangle there, right? And it's the y value. So we're going to do Pythagorean Theorem again. 1/2 squared plus, and notice I have it in brackets because it's both the top and the bottom that are getting squared, plus y squared equals 1 squared. Everybody go with that? Can anybody tell me what 1/2 squared is? Hmm? 1/2 times 1/2. 1/4, yeah! Plus y squared, and 1 squared is 1. So I do the algebra. I'm going to move the 1/4 over. What's 1 subtract 1/4? If I have $1 and I take away a quarter, 75 cents. So what is that as a 3/4? Thank you. And then I'm going to square root that. And technically when I square root that, I'm going to get plus and minus the square root of 3/4, which I should have actually said in the last question. But I end up rejecting the negative because it's in the first quadrant. So if you want, I can just cross that out. I should have done it in the last one, but that's okay. So this is the square root of 3 over the square root of 4, which is 2. Does everybody see that? I skipped a step on that one. So that means my y value is root 3 over 2. Yeah? So what was y again? Y was my, what value? Sine or cosine? Sine. And my x was my cosine. So in quadrant 1, when I have 60 degrees, what's my sine value? Root 3 over 2. And at 60 degrees, what's my cosine value? 1/2. Now this is the hard one. Maybe, I don't know. Some people can divide fractions really easy in their head. Remember, tan is sine theta divided by cosine theta. Can anybody tell me what the answer is? If I take this and divide by this. This is root 3, by the way. It doesn't magically become 3. So say it again. Okay, so I'm gonna do it like old school. I'm gonna show my work here. So this is root 3 over 2 divided by 1/2. Everybody good with that I wrote? Back in the day, we changed this to multiplication, right? And we flipped the fraction. 1/2 becomes 2 over 1. Does everybody see the 2's cancel? And what are we left with? Root 3 over 1, which is just root 3. So once you see this once, you'll remember that the 2's just cancels and just root 3. But I'll show you a trick later. Maybe we should fill this part in. So sine of 60 degrees is root 3 over 2. Cos of 60 degrees is 1/2. Tan of 60 degrees is root 3. Okay, so that was the triangle that was in this first quadrant, right? Now we're going to go to the second quadrant with 60 degrees reference angle. So what angle is that? That's 120 degrees, right? So what's sine of 120 degrees? Root 3 over 2. What's cos of 120 degrees? Negative 1 over 2. What's tan of 120 degrees? Negative root 3. Okay, now we're going to go into the third quadrant. And if I travel all the way to the third quadrant, the reference angle is 60. My related angle is 240. So what is sine of 240 degrees? I'm sorry? Positive or negative? Negative root 3 over 2. Cos of 240 degrees? Negative 1/2. Tan of 240 degrees? Is it positive or negative square root of 3? Positive, because this time tan is positive, yes. Okay, now we're going to go to the fourth quadrant and go all the way over there. Yes? And the reference angle was 60 degrees. What's the related angle? So, what is sine of 300 degrees? Negative root 3 over 2. Remember, the ratio doesn't change, it's just the sign may change. What's cos of 300 degrees? Positive 1/2. Because remember, in the fourth quadrant, cos is the only one that's positive. And tan? Negative root 3. Now, does everybody notice that the 30, 60, 90 triangle that's like this is the same as this triangle over here, except that it's just rotated. Like this one kind of flopped down and became this one, yes? So that means the side that's opposite the 30 degrees is 1/2. So I'm going to put 1/2 right there. The side that's opposite the 60 degrees is the root 3 over 2. And of course the hypotenuse is 1 still. So I'm not going to redo the proof of that. You've already done that, right? Okay, so again, sine is your what value, x or y? Y. So what's sine of 30 degrees? 1/2. What's cos of 30 degrees? Root 3 over 2. Now here's a tough one. What's tan of 30 degrees? This was a tough one. No, it was the other way around dividing. So I'm going to show my work. 1/2 divided by root 3 over 2. We change it to multiplication. 1/2 times 2 over root 3. The 2's cancel, and what am I left with? 1 over root 3. So that's the only difference. It's now 1 over root 3 instead of root 3, like the 60 degree one. Okay? So I'll write that down. Sine of 30 degrees is 1/2, cos is root 3 over 2, and tan is 1 over root 3. Okay, quadrant 2. Does everybody notice when I make these reference triangles in each quadrant that it eventually looks like a bow tie? Did you notice that? Yeah. Okay. So, second quadrant, when I rotate all the way to there, I go to 150 degrees because that's the related angle for a reference angle of 30. And what's my sine of 150 degrees? 1/2. What's my cosine of 150 degrees? Negative root 3 over 2. What's my tan of 150 degrees? Negative 1 over root 3. And you can probably, now, you see the gist of this, that you could probably finish the rest of this chart. So let's just keep going now. 210 would be negative 1/2. Remember, yesterday's lesson had 2 ratios positive and 2 negative. So you could pretty much know that, but you know that sine is negative in there anyways. But okay, so cos of 210, that's in the third quadrant, so it's still negative. And this tan is now positive. Fourth quadrant, we're going all the way to 330. So sine of 330, same ratio, different sign, negative 1/2. Cos of 330, cos is the only one positive this time, so it's going to be positive root 3 over 2. And tan of 330 is negative 1 over root 3. Okay, how are we doing? Okay, so, and if you don't believe me, try on your calculator. What's sine of 30 degrees? Do you get 1/2? Well, you get 0.5 on your calculator, but you do. Yes? Try it. It's hard to see unless you have one of those fancy calculators. If you go cos of 30 degrees, you'll get the decimal equivalent for root 3 over 2, but you could just find out what root 3 over 2 is and then verify that everything's good. Okay. Okay. When dealing with the unit circle, we are easily able to determine the exact values of the trig functions. When the exact value is requested, no calculator may be used. Okay, and so you'll see in the textbook they use these special triangles Some kids memorize the special triangles, and that's how they remember. So they know that, for instance, cosine, they can see it's of cos of 45 degrees, it's 1 over root 2. Sorry, I pointed it wrong. 1 over root 2 like that, right? Sine would be 1 over root 2, and then tan would be 1 divided by 1, which is 1, right? Same with over here. So some people just memorize those triangles. That's one way to memorize it. Another way is they take the chart, and I don't know why I have 60 degrees there, but do me a favor and actually make this 45 degrees and make this 60 degrees, because it makes more sense. And oh, maybe, hold on. Okay, we'll do it that way. Okay, I know, okay. Okay, no, I'm going to do it this way, actually. Okay, so what was sine of 30 degrees? And if you didn't know, you can take your 30 degrees, and sine is opposite over hypotenuse is 1/2. And I don't know if you saw a little bit of a similarities between the 60 family and the 30 family. That it was just the cos and the sine. Like if we go back to the last page, if we look at this, you can't really see all at once here. But if you look at this, do you see that sine of 60 degrees is the same as cos of 30 degrees? And then cos of 60 degrees is the same as sinus. Like they switch. The root 3 over 2 becomes the 1/2, and the 1/2 becomes the root 3 over 2. And if you look at this, sine is root 3 over 2. But in the cos of 30, it's root 3 over 2. And this is 1/2. That's what I'm trying to say there. The x and the y switch spots, right? Yes? And then tan of 30 degrees, this divided by this, you see, is it root 3 or 1 over root 3? Yeah, 1 over root 3. And this divided by this, that is root 3. And in the 45s, you can see on the 45 triangle, it's 1 over root 2. Okay, so some people write this out 50 million times, or they do the triangle 50 million times and memorize it. But I found, actually on YouTube, somebody figured out that there's, your hand will memorize the whole thing. So if you take your left hand, and I'll demonstrate. Okay, there's my left hand for the people that are watching this video. This is 0 degrees. This is 30 degrees. This is 45 degrees. This is 60 degrees. And my fifth finger is my 90 degrees. So, and I don't know if you noticed this yet, but when I say x is xy, does everybody notice that that was alphabetical? Did you ever notice that before? Okay, and cosine, sine is y, cos is x. Do you see that's alphabetical as well? So it's easy to memorize, right? Which one's which? Yeah? Okay, so you see how cos is first? Cos is on this side, sine is on this side. Okay, everybody good? Okay, so here's how it works. If I want to know what cos of 30 degrees is, I put down my second finger, that's the 30 degree one. And if I want to know what sine is, I know how many fingers there are, 1. And notice that all of these are over 2s, except for this one, but I also told you that 1 over root 2 is the same thing as root 2 over 2. So if I want to know what sine of 30 degrees is, I put that 30 degree finger down. I know that there's 1 finger left, so my answer is 1 over 2. If I want to know cos of 30 degrees, I have 3 fingers left. It's root 3 over 2. Root 3 over 2. What am I? Cos, root 3 over 2 right there. Okay? So if I want to know, say say the 60-degree one, I'll put the 60-degree down. So if I want to know what sine of 60 degrees is, you see I have 3 fingers. Sine of 60 degrees is root 3 over 2. 3 fingers, root 3 over 2. The numerator, does everybody see what I'm doing? Yeah? Kinda? You'll see all these grade 12 kids looking at their fingers during the exam, and it's so funny because everybody's in the CAF writing the provincial exam and they're playing on their fingers because of this little trick. Okay? And then cosine is the left side. I have 1 finger, so cos of 60 degrees is 1 finger, so 1 over 2. So it's not as hard as you think to memorize these things. They're little mnemonics. You can probably Google anything tonight and they can come up with exact values per unit circle. Now, I'm going to blow your mind here in a second, so just hold on. But we didn't talk about the 45. If I put the 45 down, I have 2 fingers, and that's where I get the root 2 over 2 and the root 2 over 2, right? The 2 fingers, root 2 over 2. So it's acceptable to say root 2 over 2 or 1 over root 2. It's the same thing. I already proved to you it was the same thing. Okay, now here's the cool thing. You're thinking, how am I going to memorize this tan thing then? Watch this. If I want to know tan of 30 degrees, you have to use your left hand. Okay, you put your hand out. Tan of 30 degrees is that finger there. Put that finger down and go like this. 1 over root 3. 1 over root 3. Tan of 30 degrees. 1 over root 3. There's 3 fingers at the bottom, 1 on top. 1 over root 3. And yeah, if I want to know 60 degrees for tan, put the 4th finger down, turn your hand. There's 3 fingers on top, so I know it's root 3. Again, the 45, if I put the 45 down and switch, I have same numbers on top as the bottom, so it's the 1. Same numbers top and bottom, so it's 1. Okay, so in order to find the exact value, the first thing you need to know is, because the hand trick, honestly, most kids use the hand trick once they get how to use it. So sine of 225, you have to know what what family it's in. So does anybody know what related angle 225 would be? 45. So we know it's 45 is the reference angle, and make sure you have a degree symbol. And which quadrant is 225 in? 3. Now, remember the cast rule says that in quadrant 3, the only thing that's positive is tan. So you better have, for your ratio, sine better be what? No, negative, because tan's the only thing that's positive there, right? Okay, so we're going to use the finger trick. 45 is the middle finger we put down, okay? Which means I have 2 fingers on the left hand side, or on the right hand side, which represents sine. So that's root 2 over 2, or you could say 1 over root 2, it's up to you. So it would be negative root 2 over 2 is my answer. Okay, so moving on. And if you want, I'll have this here so we can do this quicker. Once you get good at this, it's really easy, actually. Okay, first off, 120 degrees, what's the reference angle? 120 degrees, what's the reference angle? 60. So 60 is my 4th finger. Put it down. So sine is, you have 3 fingers there. So what is that? Stop it. Root 3 over 2. And is it positive or negative in 100? No, they're all over 2. Everything's over 2. It's all over 2. They're all over 2. It's actually all radicals over 2, and I'll show you this. If I go back up here, 1 over 2 is the same thing as root 1 over 2. Does everybody agree? So you see I have root 1 over 2, root 2 over 2, root 3 over 2. Like it's just radical of the number of fingers over 2. Radical number of fingers over 2. There you go. Okay, going back. 210, what's the reference angle? 30. It's 30 past 180, right? So 30. So what finger's your 30? Put your second finger down. What's cos? The 3 fingers. So what's my answer? Root 3 over 2. Is it positive or negative, though? Negative. No flipping. Only tan is flipping hand. We're looking like this. Okay. Okay, 330. What's the reference angle for 330 degrees? 30. Put what finger down? Second finger down, right? And we have to twist for tan. So what's my answer? 1 over root 3. And is it positive, negative in that fourth quadrant? Negative. Bada bing, bada boom. So easy, right? Because the fourth quadrant only cos is positive. 315, what's the reference angle? 45. Which finger do I put down? Middle. Sine is this side. So how many fingers? 2. So root 2 over 2, or you could have 1 over root 2. It doesn't matter which one you have. But what sign is it? It's negative. You don't have to put both answers down, by the way. But I want you to get very familiar that they're both the same, okay? Because some of my worksheets will have answers of negative 1 over root 2, and some of my worksheets might have root 2 over 2, and you have to know that you did it right. Okay, 45. 40 is 45. So we put our middle finger down. What do we get? Root 2 over 2. And it's positive because it's in the first quadrant. I'll even put or 1 over root 2. Okay, 240. 240, what's the reference angle? 60, which finger is that? Your ring finger. Put it down, twist. Root 3. You can put over 1, but you don't need it over 1, right? And so is it negative? No, it's in the third quadrant, man. It's positive. Okay, now we're going to do the 90 family. Huh? The 90 family, we don't draw. Recording, hold on. That the radius is always 1. So when I go this way out, what's this coordinate right here? 1, 0. What's the coordinate right here? 0, 1. What's the coordinate right here? Negative 1, 0. What's the coordinate here? 0, negative 1. Remembering that cos is x, sine is y. So this family contains all related angles of 90. So that would be 0 degrees, 90 degrees, 180 degrees, and 270 degrees, and also 360 degrees. I went back all the way around. So without the use of your calculator, what would sine be? Sine of 270 degrees. Here's 270 degrees. Sine is my x or y. Y, so what's my answer? Okay, try it on your calculator. Do you get negative 1? Look at that. I tell you no lies here. Okay, I'm going to skip tan for right now. Let's go to cos of 180 degrees. So go all the way to 180 degrees. Which one do I look at? The x or the y? The x. So what's my answer? Negative 1. Okay, now remembering that tan is what divided by what? No, it's y over x, actually. Y over x. So if I'm at 90 degrees and I take y and divide by x, I'm just going to write this down. It's going to be 1 and divide by 0. Can you divide by 0? No, that's like the biggest thing in math you cannot do. It's like pure danger zone. And does anybody know what you get? Holy, you just told me you couldn't divide by 0, and you're telling me the answer is 0? That means you could divide by 0. You get an error on your calculator. But in math terms, it means undefined, because you can't actually do that process, right? You can't do that function. You can't go 1 divided by 0. You can't divide by 0. You get undefined. Now the next one, 270, again I have -1 divided by 0. What do I get there? I get undefined. And again, what do you get on your calculator? Error. And do not ever leave it as 1 divided by 0. You will not get any marks from me. You have to make a decision and tell me if it is undefined or 0. So just for fun, let's do an E. What is tan of 180 degrees? What's tan of 180 degrees? It's 0 divided by -1, and what do we get for that answer? Can you go 0 divided by something? Yeah, you can. And what's your answer? It's 0. Do you see what I'm saying? You can't just leave it as this fraction here. You actually have to make a decision. Tell me if it's undefined. Tell me if it's 0. So, anyways, so now we're going to actually start solving here. We're going to go the other way. We're going to look at our fingers or later, or we're going to look right here. Remember, sine is our y value, right? Sine is our y value. So where is our y value -1? Where is our y value -1? 270. So that means our angle, theta, is equal to 270 degrees. So we just solved that, what it is. So just for fun, let's go to a calculator. And how would I solve this on my calculator? I would punch in what? Inverse sine of -1. And you will get 270 if you're in degrees, right? Okay, so -90, the reason why you get -90 is the inverse function only places angles in certain spots. But think about this for a second. If I traveled -90 degrees, where would I end up? The same as 270 degrees this way, right? Those are, and we don't really get into in grade 11, but those are called coterminal angles. We do it in grade 12 more. Okay, √3/2. So first off, you got to think, where is sine √3/2? And this is where the fingers come in really good, because you need the sine on your right side with 3 fingers. So what reference angle is that? 60. So I know the reference angle is 60, but I just got to place them in which quadrant that I have a negative trig ratio. So where would that be? Where is sine? Here, I'll put the cast rule up just so you can see a visual. Where is sine negative? 3 and 4, right? So which related angles that are referenced to 60 are in these 2 quadrants? 180 plus 60 is 240, and what's that one? 300. Oh, it's all coming together now, right? Okay. Uh-oh. Where is tan theta undefined? The only way tan is undefined is if I do that bad thing in math, which is divide by 0. So look back up here. Where am I dividing by 0? 90 and 270. So theta equals 90 and 270 degrees. Where is tan -1? We know from our fingers flipping and all that, the 1 is the 45 degree, right? So now we need to look at our cast rule. Where would tan be positive? Sorry, negative, because it's -1. It would be here and here. So now I need to find, again, my reference was 45. Which angles are there in 2 and 4? What would this be? What's 180 minus 45? 135. And what would this one be? 315. Very good. Okay, so maybe at home, I want you to fill this in. This is essentially your hand, right? What's the coordinate at 0 degrees? What's the coordinate at 0 degrees? No, at 0 degrees, right here. 1, 0. What's the coordinate at 30 degrees? 30 degrees is your cos and your sine. So what would that be? Root 3 over 2. This is where your hand comes into play. 30, root 3 over 2, 1/2, right? 45, what's the coordinate? Root 2 over 2, root 2 over 2. 60, 1 over 2, root 3 over 2. And 90 degrees is this spot right here, so what's the coordinate right there? 0, 1. Remembering that cos theta is your x, and sine theta is your y, and tan is y divided by x. Does everybody see that? 0 divided by 1 is 0. So fill in the rest. I'll give you a chance to fill it in. We can go over it on, so then because cos is the x, then cos of 30 degrees would be root 3 over 2. Sine would be the 1/2. And then if I divide sine divided by cos, I get 1 over root 3. And then this would be root 2 over 2, the x. This would be the y. And then x divided by y gives me 1. This is my x. This is my y. And I get root 3 over 2 divided by 1/2. So yeah, I get root 3. And then this is my x. This is my y. Then y divided by x, you can't divide by 0, so we get undefined. And so you'll notice some patterns of what's going on here. So that's another way you can memorize it as well.